Let's briefly review the Bluetooth frequency spectrum. The ISM radio bands are defined and controlled by the International Telecommunications Union. The frequencies in this spectrum are reserved for industrial, scientific, and medical usage other than telecommunications. Many of these devices can produce powerful emissions that can disrupt radio communications using the same frequency. While the ISM name implies usage for research and industry, we find the 2.4 GHz band used for microwave ovens, and today in 2015, many children's toys come with Wi-Fi. Perhaps the greatest growth is in short-range, low-power communication systems such as Bluetooth, Wi-Fi, cordless phones, and NFC devices. The conclusion? Bluetooth shares its frequencies with a lot of other devices. Let's take a look at how you can observe the spectral situation in your development environment. You want to get started by powering up your Sodera unit and connecting it to a computer running ComProbe software. Now you need to configure the Sodera unit to capture spectrum data. From the Sodera window options menu, select Capture Options. The Capture Options dialog opens. In the Wireless Technologies section, check the Spectrum option to activate it. Now select the RF sample interval of 20, 50, 100, or 200 microseconds. Note that the lower the interval, the more memory that is used during the capture. Click on OK. The capture options are now saved to the Sodera unit and will remain as set until changed. Now that the Sodera unit is configured to capture spectrum data, you begin the capture process by clicking on the Record button. While the Sodera unit is recording traffic from detected Bluetooth devices that are within range, it is also capturing the spectrum data. Once you have recorded sufficient data, you can begin the analysis process by clicking on the Analyze button. From here you can observe the spectrum data in the coexistence view. Note that if you save the capture file, the spectrum data is also saved as an SWSF file. Here we see the coexistence view of a capture file. In the 2.4 GHz timeline, we can see classic Bluetooth and Bluetooth low energy packets. In the center we have selected packet 1104. This capture file includes spectrum data. To view the spectrum data, select Show Spectrum from the Spectrum menu. If the capture file did not have an associated .swsf file, this menu would not be active. Now the spectrum data is visible in the timeline. The packets overlay the spectrum data. The spectrum power level is shown as a heat map. The map is a gradient from dark blue to white. Darkest blues represent higher power levels, and white represents lowest power levels. The dark blue represents 2.4 GHz RF levels of -15 dBm and above. White represents RF levels of -100 dBm and below. You can select more than one packet to help in your analysis and to assist in viewing the spectrum directly associated with the packet. The selection box provides you with another means to focus on packets and spectrum of interest. Zoom in will expand your view of the specific packets. Applying packet text will further aid in viewing the relationship between the packet and the spectrum. Use the Coexistence View Format menu to show packet number and show packet type. To see the spectrum behind the packets, you have two options. As long as the packet is visible, you will not be able to completely see the spectrum associated with that packet. In the Coexistence View Spectrum menu, select Show Packet Outlines. This option will hide the packet legend colors and show only the outline of the packet. The associated spectrum is now visible, and the packet text, tooltip, and selection box are still visible. The heat map behind the packet is the RF associated with that packet. In the spectrum menu, select Hide Packets and Outlines. Now all you see is the 2.4 GHz spectrum heat map. The packet and packet outline are hidden. However, the selection boxes remain visible, as well as the packet text and the tooltip. Let's take a brief aside. Perhaps you are wondering what all these other heat maps are, especially since there are no packets associated with them. While we did not investigate further, it is likely that the repeating spectrum is 802.11. You could verify this by isolating your test setup and seeing if signals of note disappear. Zooming out will expand the timeline, showing more packets and spectrum data. It is helpful to use the packet text and packet selections along with the spectrum menu packet display options to keep track of packets while showing spectrum data, especially while zooming out. As you can see, the spectrum can be very busy.